Welcome to episode 3 of the Head in the Clouds video series. I am Ken Hartman, a SANS certified instructor and content creator for the SANS Cloud curriculum. Today's episode is titled Things to Remember When Using SSH in the Cloud. The major cloud service providers have made it so easy to use SSH to connect to their virtual machines that it is easy to forget some of the security implications. In today's session, we are going to review some SSH concepts, and then we will highlight some important security considerations. SSH works pretty much the same for the big three cloud service providers, but let's start by taking a look at AWS. And for those of you that have launched 1,000 virtual machines, this may feel like a review, but we're going to slow down and we're going to talk about what's going on behind the scenes and be mindful of security as we do it. Okay, we're in the AWS EC2 console, so let's go ahead and launch an instance. I'm just going to choose the default Amazon Linux 2 image, use T2 Micro, which is part of the free tier, add storage, add tags, configure the security group. We're just going to let it create a new security group, which many people do, but notice we have SSH open to the world, so that is a whole other set of issues and possibly another Head in the Cloud series. Just calling that out as we go, and then we're going to click launch, and it's at this point that we get the opportunity to use an existing key pair or to have AWS create a new key pair for us. So we're going to call this one demo, and here's your one and only chance to download the key pair. So I'm going to call this demo, and I'm going to save it into my downloads. And then I'm going to say launch the instance. Okay, so I'm going to CD into my downloads directory, and there it is. And now if I paste that string, I may or may not be able to connect. What's going to happen? When you see this message is intended to prevent a man-in-the-middle attack. So the very first time that you connect to an EC2 instance, you should expect to see this. In subsequent connections, assuming that the DNS name has not changed, you should not see this message. So don't just mindlessly blow past this warning. Think about what it's telling you. And one of the things that it's doing is it's providing you with the fingerprint for the key. And then it's going to put that into a file. So I'm going to say yes, and then, oops, I'm getting a warning. The reason why I'm getting a warning is because I don't have the appropriate permissions on my demo.pem file. It says the default permissions of 755 are way too open. So let's go ls-als and take a much closer look. So here we can see the permissions. So what I need to do is change to 400 permissions. So I'm going to go chmod 400. There we go. And to look at the permissions again, now see how it's read by the owner only. So now if I up arrow, I should be able to connect to that EC2 instance. Now notice I did not get the warning because I've already connected. So we've authenticated to our EC2 instance using SSH public key authentication. Now let's take a look at that public key. We can see that it's a RSA type of key, and that here is the public key. Next, let's take a look at the private key. To do that, I need to exit back out, and then I'm still in my downloads directory, so I can go cat and then just list out that demo key. And we can see that it starts with RSA private key and ends with RSA private key as well. Now this key should be carefully protected. And of course, even though I've showed it to you, I'm going to delete it immediately after this recording. But I've seen various organizations make copies of this key and put it in their box.com account, for example, and share it across multiple production operators. But let me ask you, if everybody's logging in as EC2 user using the same private key, how do you have accountability for who is making which changes on your virtual machines? Okay, the next thing that I wanted to do was take a look and see what it looks like in the console. Here I can see that I have a pre-existing key prior to me launching this virtual machine, and I have the key that was made when I launched this virtual machine. But just looking at this, I cannot tell which key is older than the other, and this has been a frustration of mine, but fortunately AWS has added the ability to tag the key. So let me show you real simply what I would recommend that you do. Let's go and add a tag, and let's call that create date, and then we'll put in today's date, which is 2021-04-16. And then what I can do is I can even come up here and I can have it display in the console. There we go. So this may help you with key management because you need to be rotating your SSH key pairs just like you would rotate your AWS access keys and your passwords for all user accounts. But I can tell you that in many organizations, the SSH keys are neglected. Okay, if it's so important to rotate your keys, how would you go about doing that? Well, let me show you. To generate a public-private key pair, we use the SSH keygen command. Then we need to provide it a location and file name. Notice that by default it is stored in the SSH directory and given a name of ID_RSA. But I want it to be in the current directory, so I use a single period, and then I'm going to give it the name of demo2. Then I'm prompted for a passphrase. A passphrase protects the private key above and beyond the operating system protections of the fact that I'm creating it in my home directory. There we go, and it gives it a key fingerprint. Now if we do an ls, we'll see that we have two new files. One is called demo2, which is my private key. Notice that it didn't tack on .pem. That is something that AWS does, but we'll see that the demo2 PEM file has a very similar structure to the other private key that was generated by AWS. Notice that the key material is different. Again, that is something that you definitely want to make sure you're going to protect, but I'm going to delete it when we're done with this talk. The next thing that we want to do is take a look at our demo2 pub file. And here it looks very much like that authorized key that we saw on our virtual machine that we connected to earlier. Now that we've generated a public key, we could go ahead and insert that into our virtual machine. So the easiest way really is just to copy it, then to SSH in, and then we want to modify that authorized key file. Now we should be able to log in with either one. So we've authenticated with the other private key, but we're still logged in as the EC2 user. While we're still logged in, let's go ahead and take a look at var log secure. And we can see that we've got multiple times where we have a message that says accepted public key for EC2 user. So let's go ahead and do a grep for that string. We can see that we have two different SHA-256 values. And where does that SHA-256 come from? That is the SHA-256 hash of the public key. So the easiest way to demonstrate that is if we exit out of our SSH session, and then we can use SSH-keygen using the -lf, and then we reference our pub file. And we can see that it does indeed match. What about the other one? Well, we don't have a local copy of that one, so let's log back into our EC2 instance. And then if we cd into our .ssh directory and do ls, we can see that we have this authorized keys file. So here again, we could use the keygen. And there we get both of them. The point of this exercise is you have to monitor your SSH authentication logs, not just for the username, but also the SSH key hash that was used. And yes, the public key is public, but don't let an attacker insert their public key into your virtual machines. You may want to use file integrity monitoring for your .ssh folder. Also, it's very important to know the scope, age, and the provenance of all SSH keys on all of your systems, as well as to which identities each key is bound. Well, my hope is that that information has helped you up your cloud game when it comes to SSH. Also, if you can, avoid SSH completely. The major cloud service providers each have provided options, but each option is different, so that you can avoid having to manage SSH keys across your cloud fleet. And that wraps up today's episode. If you have thoughts or comments on today's episode, feel free to chime in via our moderated Google group by shooting a note to headinthecloudsecurity@googlegroups.com. Stay tuned for another installment of Head in the Cloud as announcements of new episodes are made on the SANS Cloud Security Twitter feed. And meanwhile, be sure to check out our other great videos on the SANS Cloud Security YouTube channel. Until next time, take care.